Well, hi there. I'm Borna, your organic chemistry tutor, back today with another mechanism problem that I promise you're gonna like. Let's get started on it. Okay, I have another mechanism problem for you today. You should be able to do this if you have learned carboxylic acid derivatives. If you have, pause the video and try this on your own and then come back. All right, let's see what's going on here. First of all, we're using lithium aluminum hydride that is probably going to reduce this ester. Well, there's nothing else to be reduced. So I'm going to think that that is there to reduce the ester. And I know that the ester is going to be reduced to a primary alcohol. So if I were to number things and say this was 1, this was 2, this was 3, this was 4, this was 5, and then let's say this was 6, this was 7, this was 8, this was 9, excuse me, I'm going to think that this is probably 1, and 1 is connected to 2. There is no reason for this bond to be broken, and crucially, I have an acetal in the starting material, which is right here, carbon 9, and I know that the acetal is not going to undergo any kind of transformation with lithium aluminum hydride. So I'm going to say that acetal probably ends up somehow being this acetal in the product. So the carbon of that acetal, which is equivalent to an aldehyde essentially, is probably going to be this. So I'm going to number this 9. And then basically this is a symmetrical molecule. 2 and 9 are connected by 3, 4, 5 on one end, 3, 4, 5 on one end, and then 6, 7, 8 on another. So let's go ahead and see if this makes sense. Now, as for the bonds that are being made and the bonds that are being broken, as usual, I'm going to use red to show the bonds that are being broken. I'm going to use green to show the bonds that are being made. In the starting material, obviously, since I'm reducing the ester, this bond is being broken. Carbon 1 is being reduced, so basically 2 bonds to hydrogen are being made. So there's that. The O-methyl is being released, so this bond is being broken. And interestingly, the oxygen connected to carbon 5 is getting connected to carbon 9. Let's see if there's any other transformation that I could identify. I don't believe so. And as for what makes sense to happen, it makes sense for the ester to basically abstract a hydride from lithium aluminum hydride like this to open up the carbon-oxygen double bond. Now let me draw that structure down here. And I'm basically, as usual, proceeding with 2 strategies at the same time. And there are 2 parallel strategies that I usually use. I try to think of what makes sense to happen, and at the same time, I try to locate the carbons of the starting material in the product to the best of my ability, and I'm not afraid to number the carbons wrong. If I number them wrong, I just go back and correct that. No problem. And these 2 strategies in tandem are supposed to help me do the mechanism. Now, with the ester accepting a hydride, now I'm at a tetrahedral intermediate, which is basically a carbon connected to an oxygen with a negative charge and a leaving group which has the ability to expel the leaving group and recreate a carbon-oxygen double bond. And it does this because the carbon-oxygen double bond is remarkably stable. So basically, this is going to give us a structure looking something like this. Now, this aldehyde itself is pretty reactive in presence of lithium aluminum hydride. So it's going to abstract another hydride from lithium aluminum hydride, go to an alkoxide. So it's going to look something like this. I apologize, the structure doesn't look very pretty. Sorry about that. So it's going to go to an O- right here. I have an O-methyl right there. And I have another O- right here. All right. Now, this is like as much progress as we can make before we add acid. Well, I really hope you liked this video, and if you did, please don't forget to hit the like button. That's going to help my channel a lot. Also, subscribe to this channel, please, to see more solved problems, tutorials, and tips and tricks. You're going to benefit from it, I promise. I'll see you in the next video, and take care.